How might this knowledge help in advancing battery technology? What is differential thermal analysis, DTA, and how does it indirectly measure the change in heat during temperature changes? How does DTA express heat absorption and exothermic reactions, and what is the temperature difference, delta T, represented in this process? What are the challenges associated with analyzing the DTA curve quantitatively, and why is this a limitation for some applications? How is the development of differential scanning calorimetry, DSC, driven by the need to overcome these limitations in DTA analysis? What is DSC, and how does it differ from DTA in terms of its approach to measuring heat flow? Can Davis Zurins manufacture solid-state sodium-ion batteries made from seawater in Latvia? How does DSC control the temperature during its analysis, and what role does this play in its ability to measure the heat flow in a more precise manner? What relationship does DSC measure between the difference in power, heat flow, input to the sample, and the reference material, and how is this relationship represented in DSC curves? What are the key characteristics of DSC curves, and how do they help scientists interpret thermal behaviors in materials? Why are high resolution and sensitivity considered main features of DSC, and how do these features improve the accuracy of thermal analysis? How does DSC not only replicate the functions of DTA but also offer the ability to quantitatively determine thermodynamic parameters like enthalpy, entropy, and specific heat? What makes DSC a versatile tool in both applied material science and theoretical research? How does DSC measure the rate of heat absorption or exothermic reactions in a sample, and why is this rate or heat flow rate DH/dt an important parameter to study? How is the heat flow rate DH/dt expressed in DSC, and what does this tell us about the thermal characteristics of the sample? How does DSC use temperature, T or time T, as the horizontal coordinate? And why is this crucial for plotting the relationship between heat flow and temperature changes? What thermodynamic and kinetic parameters can DSC determine? And how do these parameters enhance our understanding of a material's thermal properties and behavior? In what ways does DSC contribute to understanding the heat-induced transformations in materials? And why is it a valuable tool in both practical applications and theoretical studies of thermodynamics? What is specific heat capacity? And how is it defined in terms of the amount of heat required to raise the temperature of a substance? How does specific heat capacity vary across different materials? And why is it an essential thermodynamic property to understand in thermal analysis? What is the significance of the heat of reaction, and how does it relate to the energy change that occurs during a chemical reaction?